Okay, in this concept we're going to look at solving radical equations. Now, radical equations are equations with radicals that have variables inside the radicand. Okay, this equation is solved by raising each side of the equation to a power equal to the index of the radical to eliminate the radical. Meaning if you have a square root, you raise that, to the power 2 to get rid of the square root, right? If you have a cubic root, you have to raise that to the power 3 to get rid of the cubic root, etc., etc. Okay? Let's look at some examples. Solve the following radical equations. Square root of x plus 1 equals x minus 1. Now, like we said, the first step is to raise both sides to a power that's the same as the index of the radical. So here it's a square root, we have to raise both sides to the power 2. Okay, square both sides. This gives us x plus 1 equals, on this side we get x minus 1 all squared, right? So we get rid of the square root here, so just x plus 1 like we said. And then here we can actually factor this. So we get x squared, right? Minus 1 times minus 1 is plus 1, and then x times minus 1 is minus x times 2 is minus 2x. Okay? Then we just do a little bit of algebraic manipulation, just combine like terms, right? So we have x squared. We just, flipped it, brought it to the left side, just so we have it in standard form. X squared, and then minus 2x. And then minus x, right? Minus x goes to the other side, so it's with this expression, so it has a negative sign. And then this plus 1, right? And then this plus 1 becomes a minus 1, again, going to the other side, right? So minus 1 equals 0. So plus 1 minus 1 is 0. Minus 2x minus x is minus 3x, and then the x squared is x squared. So we have x squared minus 3x equals 0. Okay. In this case, factor the greatest common factor, which is x. So we have x times x minus 3 equals 0. Oops. Here we can use the zero product property. So x equals 0 and x minus 3 equals 0. Both conditions are true. So our result is x equals 0 or x equals 3, right? Because 3 minus 3 is 0. Okay? And be sure to always check your solution by substituting the solutions back into the given equation. All right? Next example. We have the square root of x plus 4 minus square root of x equals square root of 2. Now here it looks a little more complicated because if we square this, we're going to have two expressions that have radicals, and then we have to multiply them in a binomial expansion, etc., etc. One way to get around this, in this case, is to bring the square root of x to the other side, right? Such that when you do the binomial expansion, it's going to be simpler because you have just square root of a single variable and the square root of a single number, as opposed to expanding the square root of a binomial and the square root of a monomial. Okay, so that's why we want to bring to the square root of x to the other side of the equation. So then we'll have square root of 2 plus square root of x on the right hand side, and then on the left hand side we have square root of x plus 4. So now if we square both sides, right, we'll have x plus 4 on the left hand side. And then on the right side, we can actually expand this. And we'll have square, so the same as expanding a binomial. Okay? First squared, second squared, and then first times second times 2. Okay, which is the power. So first squared, square root of 2 squared is 2. Second term squared, the square root of x squared is just x, right? Not x squared, okay? Do not make this mistake. This mistake is very easy to make, but it will throw off the entire solution. So square root of x squared is x. Okay? And then first term times second term times 2. So square root of 2 times the square root of x times 2. Again, some algebraic manipulation, subtract x from both sides, because here we have an x and here we have an x. So we can subtract the x, and this way we get rid of these x's, right? So now we have 4, and then we can bring this 2 to the left-hand side. So 4 minus 2 equals 2 square root of 2x. Well, how did I get this? So square root of 2 times square root of x is the same as square root of 2x, okay? The product property of radicals, okay? So 4 minus 2 is 2 equals 2 square root of 2x. The 2's factor out, so you can divide both sides by 2. So you have, you'll have, you have 1 equals square root of 2x, and then you can square both sides to get rid of the square root. So you still have 1 squared is 1, and then square root of 2x squared is 2x. Okay? So 1 equals 2x, so x equals 1/2. Okay? And again, always check the solution by plugging in the result in the given equation. Next example, square root of 4x plus 1 equals 3. Square both sides, right? This is a little bit of a typo, so this should be like that. So the square root of 4x plus 1, and then that is squared, okay? So meaning the square is not under the radical, it's above the radical sign. And then on the other side, 3 squared, okay? So the square root of 4x plus 1 all squared is we get rid of the radical with the square, and then we get 4x plus 1, and then on the other side we have 3 squared, which is 9, and then just solve. 4x equals 9 minus 1, which is 8. So x equals 8 divided by 4, which is 2. Okay? And again, you can always check to make sure that you've got the right solution. You can plug in 2. So 4 times 2 is 8, plus 1 is 9. So the square root of 9 equals 3, is it? Well, square root of 9 is 3, which does equal 3. So this is good. Okay. Next example. Square root of x minus 5 equals the square root of 2x minus 4. Very straightforward. Square both sides. So this squared and this squared. So we'll get rid of the square roots, and then we have x minus 5 equals 2x minus 4. And here we just want to combine like terms, so we can bring the 2x to the left-hand side with a negative sign. So subtracting 2x from both sides, which gives us x minus 2x. And then on the right-hand side, we have minus 4 here, but then we want to bring this 5 to the right-hand side. So we add 5 to both sides, so we have plus 5, right? So x minus 2x is minus x, and then minus 4 minus 4 plus 5 is 1. So x is equal to negative 1. Okay. Now, if you get a number as a solution, and then you check it with the original equation, and it does not satisfy the original equation, then that number is called an extraneous solution. Okay. Sometimes you will get this. So that's why you should always check the roots that you get, whether they satisfy the original equation or not. Another thing to keep in mind is to undo a square root, you square both sides. This is what we've been doing. Okay, so if you see a square root expression, do not freeze in horror. Okay, square both sides, or square the expression. You get rid of the square root, and it becomes easier. It becomes just a simple polynomial. Monomial, binomial, trinomial, whatever. Okay. Very good. Now we have the exercises. Please pause the video, work on these, and come back for the solutions. Okay, let's look at the first exercise. So here we have square root of y plus 4 equals y minus 3. So again, to get rid of the square root, square both sides. So this squared and this squared, which gives us y plus 4 equals, so y minus 3 all squared is y squared plus 9. And then y times negative 3 is negative 3y times 2 is negative 6y. Okay? Combining like terms, we get we'll get, so we can make this 0, right? And yeah, we can make this, we can make the right hand side, left hand side 0, and then we bring the minus y minus 4 to the other side, and then so this side would be 0. So 0 equals y squared minus 6y plus 9 minus y minus 4. So this is going to give us y squared. So minus y minus 6y minus y is minus 7y. Okay, plus 9 minus 4 is plus 5 equals 0. Oops, this is a minus. Okay. So there's no straightforward way to factor this, so we just have to use the quadratic equation. Okay, so y equals minus b plus or minus the square root of b squared minus 4ac over 2a. Which, again, you can solve this on your own, but you'll end up getting 7/2 plus or minus the square root of 29 over 2. Okay, which when evaluated gives you 0.81 and 6.19, rounded off to the nearest hundredth. Okay, next exercise. Square root of m plus 5 minus square root of m equals square root of 3. So again, first off, we can bring this m to the right-hand side, square root of 3 plus m. And then we can square both sides, right? In which case we'll get m plus 5 equals, so again, square root of 3 squared is 3, and then square root of m squared is plus m, and then plus 2 square root of 3 square root of m. Okay, now we have m and m, so if we just subtract m from both sides, these will go away, right? And then we'll have 5 equals, and then we can also actually bring this 3 to the left-hand side by subtracting 3 from both sides. So 5 minus 3 is 2, right? So this becomes 2. So 2 equals 2 square root of 3 times square root of m is just the square root of 3m. Okay, so divided by 2 is 1, divided by 2 is 1. So 1 equals square root of 3m. We can square both sides to get rid of the square root, which is going to give us 1 equals 3m, which is going to give us m equals 1/3. Okay? Next exercise. Square root of 2x plus 5 equals 11. Again, very straightforward. We can square both sides. And this 2 is actually from the previous exercise, but it's very appropriately placed. So square root of 2x plus 5 squared, and then 11 squared. Okay, let's make some space. So now we have 2x plus 5 equals 121. So again, just straightforward algebraic solving. 2x equals, so we can subtract 5 from both sides. So 121 minus 5 is 116. X equals 116 over 2, which is equal to 58. Okay. Next exercise, x plus 3. Square root of x plus 3 equals the square root of 3x plus 9. Square both sides. And you'll get x plus 3 equals 3x plus 9. This is a forward arrow, I promise. Now we can just combine like terms. So we'll have x minus 3x, and then we'll have 9 minus 3. So x minus 3x is minus 2x. Okay, and 9 minus 3 is 6. So x equals 6 over negative 2, which is equal to negative 3. Okay, last exercise. We have 3 times the cubic root of 5y minus 1, and then minus 2 equals 0. So first off, what we could do is we want to bring this and this to the right-hand side, so we can isolate the root and then be able to square things, right? So what we could do is we could just say square root, cubic root of 5y minus 1, okay, equals plus 2 divided by 3. Now we can square, not square, but cube. Okay, take the cube of both sides. Okay, raise both sides to the power 3. Remember, you have to raise the expression to the same power as the index of your square root. Okay, or your root, the index of your root. In this case, it's a cubic root, not a square root, so we have to raise it to the third power. We have to raise both sides to the third power. Okay, so this gives us. So again, cubic root and third power, both of these cancel out. So we'll have 5y minus 1 equals 2 cubed, which is 8, divided by 3 cubed, which is 27. We can add 1 to both sides, so that gives us 5y equals 8 over 27 plus, so again, just to have this one is added to the whole fraction, but it's equivalent to 27 over 27, right? Because I want the same denominator, so I can do the addition, by hand. So I'm just going to write 27 over 27, right? So, which is actually 8 plus 27 is 35 over 27, right? So y equals 35 over 27, and then so divide both sides by 5 or multiply by 1/5. Divided by 5 is 1, divided by 5 is 7, so y equals 7 over 27. Okay, this is it for this concept. See you in the next video.